Okay, so welcome to my presentation on Go VIA. So yesterday, Richard from Oracle opened with, share your stuff. If it's a blog, if it's a video, if it's on code on GitHub or something, someone or an AI will find it and hopefully find use for it. So this is my contribution to the world, and hopefully in 10 years, it might be as popular as RV tools. So like short agenda, some context, some like whys, the decision making on some of the choices. How does it actually work? How simple is it to actually get going? I'm going to explain some stuff about the REST API and the GUI, quick overview of the GUI, quick overview of the REST API, and then we're going to end with a demo. So some context. So I work for VMware. I'm a VMware Cloud Foundation specialist. And one of the functions when you are creating your private cloud is called VIA, VMware Imaging Appliance. And it was inherited from EMC. So back when EMC did the VxRack, this was their software for doing bare metal provisioning and configuration of Cisco switches, et cetera, et cetera. So basically, VMware inherited this code, which is Java-based from EMC, and no one's touched it for like 5 to 7 years. There are some issues with VIA, or there are some issues with VIA. So one of them is it doesn't support UEFI. So if you want to use it, you need to go back to BIOS, which meant, like a lot of configuration of the hardware, and you're kind of also missing out on some features like Secure Boot, which is like everyone should be using Secure Boot. Like, please use Secure Boot. It didn't have any support for IP helper, so you needed to have the appliance on the same layer 2 network to do DHCP broadcasts, and that's not, always feasible. Sometimes you want to have, your imaging appliance on another network. It didn't support nested environments, or rather, it actually blocked nested environments. So if you wanted to spin up a virtual nested data center in a lab or for some kind of use, you couldn't, because the MAC address range that VMware uses was actually blocked in the application. And it didn't do the prerequisites that were kind of required for VMware Cloud Foundation. And finally, it was announced deprecated. So basically, this all started by me reaching out to the product manager and asking, like, hey, what's the roadmap for VIA? Like, is it going to get an upgrade anytime soon? Or are we going to start supporting UEFI and Secure Boot and all the nice stuff? And the answer was like, no, we're going to deprecate it. So my second question was, well, how are people going to do imaging then? And our response was sort of like, well, the customer will have to figure that out themselves. Either they can use, an ISO image with out-of-band management to image their hosts, or you can buy a pricey solution like RackN and do it, the corporate way. So I was like, okay, challenge accepted. So I'll create my own version. So I sort of looked at VIA and took the things that I kind of liked about it and how it worked, and I started coding, because I wanted a new project to work on, and I wanted to learn how to code Golang and JavaScript. So I started writing Go VIA, which is my Go-based implementation of VMware Imaging Appliance. So unlike VIA, it has full support for UEFI. It also supports x86 and ARM. So in the future, if you're using an ARM-based hypervisor, you can use this for that as well. Full support for Secure Boot, since it actually supports UEFI, so you can run a secure data center. It does support IP helper. And for those that don't work in the networking industry, a IP helper is basically a listener on a layer 2 network. So if your bare metal server does a DHCP broadcast and says like, hey, I'd like some DHCP, please, and there's no DHCP server on the same network, the IP helper will pick up that request and ship it off to the actual DHCP server, which means that you will then get a DHCP request back. It does support nested environments. It's also only tested in nested environments. So if you're building nested environments, you can use this for both bare metal provisioning and installing your virtual ESXi hosts. And it performs a lot of prerequisites for both like common ESXi things and the prerequisites if you want to then install VMware Cloud Foundation. So stuff like NTP, DNS, certificates, etc. We'll go through that. And it's not a commercial offering bound to VMware Cloud Foundation. So to use VIA, you actually needed to purchase VMware Cloud Foundation, like the whole shebang, to be able to image the servers. This has no tie to VMware. It's an open source project. So you can use this to provision whenever, wherever, without a license. And it's hardware independent. So I don't care if it's HP, Dell, Cisco, Lenovo, Supermicro, Intel. Like you can use it on anything that's x86. And you can use it to install one hypervisor or thousands of hypervisors. So the good thing with Go is it scales really easy. So you can use it for a lot of things. And because of, you'll see soon how quick it is to install. It's even worth it if you're just gonna install one hypervisor. So some whys. So firstly, like why not use off-the-shelf stuff like ISCs, DHCPD, TFTPD, HPA, and Apache to do basically the same functions that GoVia does. So initially, like this is version 2. So the initial version was actually a bunch of containers running with Docker Compose and me trying to write middleware to sort of like plumb everything that was required to be done between these different containers. But I quickly realized that like ISC, DHCPD has been around since the dawn of man. So it's pretty old and it's very static and it's very hard to like manipulate live. I looked at ISC Kia, which is like the new version of DHCPD. And it looked nice. It was open source. But if you wanted to use like a database, you had to pay a pretty hefty fee. So it was open source, but very monetized. So that didn't work. So basically, this all led to like, okay, either I try to write a middleware that everyone knows will fail one way or another, or I just write my own solution that's completely integrated. So why Golang? It's just Golang is a rising language. It was interesting. It's easy to read. There's a lot of good documentation. It's really fast to compile. It threads easily. It's just it's a very nice language to write stuff in, and it's very efficient. So the binary is 14 megabytes, but I think 12 of that is a JavaScript front end for the UI. The actual back end is like tiny. So why open source? So that's probably the most common question I get. Like, why don't you charge money for this? Some of the best things in life are free. So like, I don't intend to charge anything for this. I want people to use it and hopefully find value in it, just as I've found value from other open source software found on the internet. And it allows people to rapidly contribute and help if they find bugs or want features, etc. And a lot of people who use GoVia are in the secretive business, let's say, which means that they need to be able to verify the code that it's not doing anything malicious, to be taken into secure areas, etc. And having everything published open source means that they can do their own code verification and check that nothing malicious is being done in the code. So how does it work? So GoVia uses PXE boot, which is also probably as old as DHCPD. So I wanted something that would work with like really, really old hardware, because like most people at home don't have the new generation of servers with all the new bells and whistles. Most people have like 12-year-old hardware at home. So I wanted something that would be like require minimal configuration on the hardware and that would work for everything. And that's basically PXE boot. So I did explore newer options like HTTP boot, etc. But basically, that's only available in the last 2 generations of most hardware vendors, which kind of limited the amount of hardware, and it also required like specifically configuration of the hardware. While PXE boot is basically just start your server, press F12, wait. That's it. So the things you need to do a unattended installation are the functions of DHCPD, TFTP, a web server, and if you want some form of customization engine. So the DHCP server in GoVia is kind of special. So it's not a proper DHCP server. So most people would expect that if you do a DHCP request, you would be given a random IP address in the pool. This function of a DHCP server only implements like some RFCs that are required to do PXE boot. So basically, it will never just provide any IP to any host. It will always be that you have specified a specific MAC address to get a specific IP address at a specific time. So why I'm saying this is most people are like, I don't want to leave a DHCP server like rogue on a network. You can actually leave like Govia running because it won't just like randomly respond to DHCP requests. And it's built to be automated. So unlike ISCs, DHCPD, etc., it uses a SQL backend to store the data, and it can be tuned on the fly to provide IP addresses to end hosts. The TFTP can also the same. It only implements read. So out of security, like people, TFTP isn't that secure. So one of the security things is, don't allow people to write files to the TFTP. So you can only read stuff from the TFTP. And why I chose to write my own TFTP was to, on the fly, manipulate files. So basically, when the hypervisor is asking for a file, I can serve whatever file I want, no matter what the specific string is being asked for. And then a web server. So the web server is pretty easy. Its only purpose is to serve the kickstart config file. And in this case, also out of security, depending on the IP address that's requesting a kickstart file, I will generate a kickstart file for that specific hypervisor that's being installed. So only the hypervisor that has the right IP address, etc., can actually see the clear text password that's being sent in the kickstart file, etc. So again, like thinking about security and being able to be like dynamic with what I'm serving. And then a post-config automation. So to be able to do things like DNS, NTP, certificate generation, or whatever I wanted to do after the hypervisor was installed, I wrote a simple automation engine to just perform those kind of functions. I'm calling these functions because they're not like individual binaries. There is only one binary, and it serves all these different functions in the same binary. And lastly, it uses a flat file database. Why flat file? Like, why not use like MariaDB or some fancy SQL server? If it's something I don't really like, it's like downloading a piece of software and spending hours trying to install it and configure it and get it working. This application doesn't need anything more advanced than a standard flat file SQL database. And that means that it's really easy, like it's portable, it's easy to maintain, it sets up itself, it has no external dependencies, etc. So my goal with Govia is to take all the advanced config stuff, all the time-consuming stuff. I'll spend a few thousand hours on that so that the end user can spend 30 minutes spinning something up and have a better day. So technically, like, how does this work? So if you have a physical bare metal server or a nested server, you start it, you press F12, it will do a DHCP broadcast. So basically, it will announce like, hello, I want DHCP addresses. Or a DHCP address, and I want some options with it. So Govia will intercept the DHCPD, and if it is allowed to do a reimage, it will then answer with an offer that includes two options, so option 86, option 66, and option 67, which is basically the TFTP server address and the micro boot file that's required to kickstart the installation. So the server will receive the DHCPD, the DHCP offer, and it will ask for the mboot file from the TFTP. Now, depending on which version you've said that this ESXi hypervisor should be installed with, if it's like 7.0 update 3 or if it's 8.0 update 1 or something, the TFTPD will look at like who's doing this response, who's doing the asking. Okay, you're going to be imaged with this. I'm going to give you this mboot file. So that's why I said that the TFTP can do stuff like dynamically on the fly. So each hypervisor will always request mboot.efi. It won't request the entire like path to a specific hypervisor release because I know what version is supposed to be installed. So yeah, Govia will fake the location of the mboot.efi file and send a boot.config and the crypto files for that's used for a secure boot. So the server will load the mboot bootloader, and then it will start asking for a ton of files, including the boot.config and everything else that's actually required to do an unattended installation. Now, this is probably the most time-consuming and load-generating thing that happens in GoVia when it's actually streaming like 300 megs of data from the TFTP to the ESXi to then start doing the unattended installer. And when people ask me about like scale, like how many hypervisors can I install at the same time, like a lot, because of the entire process of imaging a hypervisor. The only thing that's like resource intensive is actually streaming 300 megs of data, and that's pretty easily done. So GoVia will serve the kickstart file and will then start a thread, which is a post-configuration thread. So to do like configuration of DNS, NTP, certificates, SSH, etc., whatever you choose, it will start a thread that's basically just looping. So it will sit idle for up to 60 minutes and wait for the hypervisor to complete its installation and then start doing the post-config. So remember the starting of a thread. So the server will then do an unattended installation based on the information that it's got from the kickstart.config. But this is sort of like basic stuff like keyboard layouts, which hard drive it should be installed to, etc. So it will reboot itself after the actual installation. And then when the hypervisor has fully booted, and after a few seconds, the ESXi SOAP API will start. And that's what the thread is constantly looking for. So when the thread detects that the SOAP API is up, it will start doing the configuration for like DNS, NTP, etc., etc. Is it still okay? It's working. So GoVia will then lastly announce that the host has completed a successful image and is ready to start being used for the next step, so vCenter or whatever you're going to use it for. So what's the installation of GoVia look like? So on the GitHub page, you'll find like 3 different options. So you can run it as a Docker container, you can download the binary, or you can compile it yourself. And that kind of depends on what you fancy. The recommended and preferred option is to just run it as a Docker container, which means that if you just install Docker IO and Docker Compose on any Linux VM, you copy paste the YAML file, and then you do sudo docker compose up -d for daemon. It will then start running in the background and you can start using it. So that's literally like 60 seconds to get started. So again, let's put all the time-consuming stuff on the developer so that the user can have a easy experience. If you're not able to run Docker because you're in a dark site or something, and you don't have the permissions to pull stuff from Docker Hub, you can just download the binary from the GitHub page and then just run it as a binary in Linux. Or again, you can also compile it. The configuration is pretty sparse. You can choose, if you have a virtual machine with multiple interfaces, you can choose which interface to serve from. Otherwise, it will serve from all the interfaces. And you can also change the default port, which is 8443. So it is HTTP REST and GUI. So like the binary is the backend, it's HTTP REST. Everything that you can do in the GUI, you can do through uses HTTP REST in the backend. So I did write a JavaScript GUI based in Angular for people that just aren't comfortable working with HTTP REST and like a GUI. So again, the front end's Angular and it's running Clarity UI, which makes it look sort of like a VMware product. So short overview of the UI, and this sort of explains like how this works. So firstly, when you log into the UI, you'll see on the left side there's like sort of a menu, and by just going down the menu in that order, you'll be able to successfully start provisioning hypervisors. So the first thing is to create a scope, and this seems kind of unnecessary since VIA only provision or hands out IP addresses to like specified hypervisors, but it's a part of the DHCP, the RFC. So create a scope, basically like if it's your management network, as an example, specify the CIDR, give it a human readable name, the start and end address, the gateway, and that's basically it. Now, there is one thing to know that like you can't use like multiple start stops in the same scope. Some people have tried creating like multiple scopes that are the same network. That doesn't work RFC wise. So if you have hundreds of hypervisors on the same management network, just input the entire range instead, because it doesn't really matter. So yeah, add a pool, pretty easy. Next, upload one or multiple ESXi images. Recommended is to input the SHA-256 hash. In that case, when you upload the ISO, it will also verify the hash to ensure that your ISO is not broken or corrupted. Next is a host group. So I wanted to keep it really simple adding hosts. So instead of adding a host and setting all the options, you create a group, which is sort of like a property container that you can then put hosts into. So look at this like a cluster. So if you have a cluster of 10 hosts, those should probably share the same properties like DNS, NTP, syslog, etc. So firstly, you create a group. Give it a human readable name. Choose which DHCP pool that this group belongs to. Select the VMware image, the ESXi ISO. And this can be like a stock VMware image. It can be a HP, Dell, Lenovo custom image. It can be a custom image that you created, as long as it's a like valid ESXi ISO. And the good thing here is later, if you image a host and then you want to re-image it with another version of ESXi, you simply edit the group, select the new VMware image, click OK, reimage the host, and then it will automatically push out that new ESXi version. Password, like notes, this is stored in clear text in the database. So anyone that has access, file permissions to the database can read this clear text password. This password should be a common password that you use for installation, and it should then be rotated to something secure. It's also the plain text password that's stored in the KS config file that's sent during the installation phase, and there's just no way to go around that. So boot device, it says optional, and that's because the ESXi installer uses something called first boot, and it's basically up to the hardware to say, like, this is my boot device, this is where I want to install it, because you may have like multiple LANs or multiple devices. Now, I've only found a certain version of Cisco servers that aren't able to present first boot. So if you have like a very, very weird piece of hardware that isn't able to present a boot device, you can override and manually enter the MPX ID to sort of force it to install to a specific device. Next one is management VLAN. So if you're using untagged, you don't need to use it. If you're using a tag for your VMK0, you need to first go into the server, the physical server's UEFI, and set to do DHCP PXE boot on that specific VLAN. And then you need to enter the same VLAN in GoVia. This means that the physical hardware will do a DHCP broadcast on that VLAN, and then the unattended installer will configure the VMK0 and the VM network using that VLAN tag. The callback URL is like this only takes you so far. It will install a hypervisor, it will do some basic configuration, but then like I don't really know what you want to do next. It might be join a vCenter, maybe it's a standalone host, you can do anything you want after this. So to enable you to use GoVia in like a pipeline, there's a callback URL. And this means that every time a host is successfully imaged, it will do a callback. So I will do a HTTP post with a JSON dump of everything related to this host to this URL. So this would be your CI/CD pipeline where you can continue to, to use this host afterwards. DNS, NTP, syslog, kind of self-explanatory. SSH, for those of you that want to have SSH enabled afterwards, this may be to perform, other day 2 operations, etc. Erase all disks, warning, it does erase all disks that it finds. Even so, if you're using fiber channel with fiber channel HBAs, and this is zoned to multiple LUNs, it will wipe all the LUNs as well. Like some people have done this. So be careful with the erase all disks. Allow legacy CPU. So some of you may have noticed in vSphere 7, we started deprecating some like really old CPUs. If you have a lab environment with like really old hardware, and we're talking like 12-year-old hardware, you can enter the allow legacy CPU to bypass the installer that blocks the legacy CPUs. Generate certificates is pretty interesting. So if you just download the VMware ISO and you do an installation, if you look at the certificate when you browse to the host, it will say in the subject alternate name field, it will say localhost.local domain. And that's kind of unsecure, but when you join the ESXi to a vCenter, it will get a new certificate anyway. So that certificate is only used, for a couple of minutes usually. If you're using VMware Cloud Foundation, we're pretty stringent on security. So you need to first go in and generate a certificate that has a correct subject alternate name. So it needs to be the FQDN of the host. So to make this easier, if you're using VMware Cloud Foundation, you can select generate certificate, and it will actually push out a valid certificate to the ESXi host so that you can then continue the installation. Last thing is create VMFS. So I kind of get annoyed if you have a cluster of 10 hosts and you have 10 data stores, which is like the last part of your boot device formatted with a VMFS. So by default, Govia doesn't create the local data store of the local disk. If you would like this data store, then you can click the create VMFS and it will be created. So when you have a host group, that's all the properties that should be common, you can now start adding hosts. So adding a host is just the FQDN, the IP address, the MAC address, and that's it. You see there's a toggle saying show advanced options. That allows you to either in the group or on a host, so host takes precedence of a group, you can create your own kickstart config file. And it's sort of like a markup language. So if you want to change like the default keyboard setting or something else, you can actually modify the kickstart config file. So adding like 4 hosts is now quite rapid. It's just 4 FQDNs, 4 IPs, 4 MAC addresses, and that's it. So if you were to reboot a host now, nothing would happen because Govia isn't listening for any installation candidate. So what you need to do now is actually click the re-image button, which sort of arms a reinstallation of that specific host. So only when you click the re-image will Govia actually respond to a DHCP request. And that's why I'm saying that you can have Govia just laying around in your management network because it won't do anything unless you specifically tell it to respond to a request. So everything I showed you, you can do with HTTP REST as well. So if you want to use Terraform, there's a Terraform provider. If you want to use Bash, you can use Bash. So these are examples in Bash. And as you can see, I've included a URL that's to the GitHub page of our Nordic lab for VMware, where these scripts are published. So you can just download them so you don't need to figure out yourself. But basically, you can create a DHCP pool. You can upload the ISO image using curl. You can create a group. You can create a host. And note here the red text. So it says re-image true. So in the UI, I showed you can add a host, and then you need to click re-image. Instead of doing 2 HTTP requests, if you want to add this host and re-image it, you can just set the re-image true. And if you then check in the GUI, it will actually have the re-image already pressed. So again, there is a Terraform provider. So I liked Terraform and I wanted to fiddle around with it and write my own provider. So if you're into Terraform, you can also use Terraform to do all the API stuff. So demo. This is what the environment looks like. where I've recorded the demo. So I wanted to show that this works with IP helper. So again, the GoVia appliance is on one subnet. The ofESXi hosts are on another management subnet. There's a router in between, and it's got IP helper configured to point DHCP requests to GoVia. So I log on to the UI, create a IP scope. So I'm going to give it a human readable name. I'm going to tell it a start IP address, an end IP address that's expected for this scope, the gateway. Click add. Now I have a DHCP scope. So now I'm going to upload the ofESXi image, and I'm going to paste in the SHA-256 hash to make sure that once it's uploaded, it gets checked. So in the background now, it's checking the ISO, and it's also extracting it to a /TFTP path, doing some like file movements that are required for PXE. Then going to add a host group. So I'm going to keep it easy and use the same human readable name to be able to see what belongs to what. Select the scope, the image that I want to use. Again, you can have multiple images, and you can just select between them. I'm going to enter our super secret password VMware one bang. I don't have any requirements for VLANs, etc. So I'm just going to put in the DNS NTP. I'm going to select SSH and generate certificates. So now I'm just going to add the FQDN, the IP address, and the MAC address for the first host. And then quickly do this 3 more times just to show you that you can do this in parallel when you're imaging these. So now I'm clicking re-image on all of these. So now the system's armed, and when a reboot is done, it's actually going to respond. So this is a nested environment. So you'll see the VM attempting to boot. So now it's got the mboot config, the mboot EFI file and the boot.config, and it's downloading all the files required for the installation. So this is streaming about 300 megs of data. So you'll see some updates in the bar, and this is based on like when the host actually does an interaction with GoVia, like getting the mboot, getting the kickstart, the SOAP API coming up again. So it's kind of like non-granular because there's not many points in time when the host actually calls home so that I know what it's doing. So it's now done the installation. It's retrieving the kickstart file, reading it. Now it's going to install accordingly. We'll soon see a reboot. And you'll see in a minute that the cancel is going to get swapped for reimage. So to not get stuck in like a boot loop where it's just like constantly reinstalling after the reboot. Once the kickstart file is fetched, that's like the last like point of no return. So that will actually shut off the listening for DHCP for that specific host. So a bit of security and a bit of like not getting stuck in a loop. So now it's booting up for the first time. So now the customization process has been waiting, listening for the SOAP API to come up. It's now configuring like DNS, NTP, etc. And because I selected generate certificates, it's now going to reboot once more. So if you only selected like DNS, NTP, SSH, it would be done now. But the generate certificate requires to generate a certificate, upload it to a HTTP REST API on the ofESXi host, and restart 2 services. And one of them is VPXD. And there is no way via API that you can restart VPXD. So the only way via API, or the only thing I can do, is reboot it once again, and it then loads the new certificate. So generate certificate requires 2 reboots. I could have used SSH and just like enabled SSH in, run the commands, and then turn SSH off again. But I really didn't want to use SSH because it's bad practice. Like everything should be done through APIs. So now you can see all the 4 hosts are completed, and that's it. So if you'd set a call home or callback, then that callback would now have gotten 4 callbacks saying that these 4 hosts have been imaged successfully, or it's now up to you to continue putting these hosts into production. So that was it. So I'm Johansson. I forgot to mention that in the beginning. I work for VMware as a systems engineer covering Cloud Foundation and HCI. And the first GitHub is to my GitHub, where I post my open source projects. The second link is to the Nordic Labs GitHub, where we post collectively all the cool demos and stuff that we do. On the VMLab.se GitHub, you'll find scripts to do a full unattended reprovisioning via GoVia, but also a full bring up of your private cloud using Cloud Foundation. And if you later have any questions or comments, etc., you can always reach me at this email address. Any questions? Sorry? A log, yeah. So you'll see in the end there's a log. It doesn't ship to a syslog, but if you're wondering, like, is it actually responding? Is it actually serving files, etc.? That log just like it dumps out the log for the internal container. And that's been very useful because there's been a lot of customers who have run this through firewalls, etc. And especially if you're using an active passive firewall and like one is responding with IP helper and the other one isn't, etc. There's always the like, is it the network's fault or is it the application? It's always been the network's fault. But having a log that says like, look, I got your DHCP request, I responded to it, but then nothing reaches the actual server, then it's very easy to use the log. Any other questions? Legacy CPU, yeah. Yes. So yeah, basically, oh, hang on, wrong way. So here, the allow legacy CPU option. So if you go onto blogs, you'll find that when the ofESXi installer pops up, you can press E and then you can edit the boot options. And there's a like override legacy CPU blocker. This does exactly the same, but using PXE boot. So basically, it's just modifying the kickstart.config parameters to allow you to use any CPU you want. So kind of bypasses it. Any other questions? Sorry, if you have a backup VLAN. How do you mean, if it configures it, or? So no, so I mean, sorry? Oh, if it, I'm not sure I follow. Yeah. So that would be, no, so that would rather be like a data operation. So the question is like, would it make sense to have a button to configure a backup VLAN? And that's sort of what the callback is for. So GoVia basically does the imaging provisioning and sort of like basic stuff that you always need to do to a host. And then if you want to do something further, then just use the callback to then trigger, whatever you want to do. And that might be simple or very, very complex. Good question. A lot of people ask, like, can I use a separate DHCP? Can I use a separate TFTP? No. The whole point with this is like one single binary, easy to like transport somewhere that may be a dark site, it may be, a normal company or whatever. But like having one single binary with no dependencies, etc., makes it a 1-minute install. So like, even if you're just going to provision like 2 hypervisors, it's probably quicker to just load up GoVia, upload the ISO, and then have it install both of them. It will save you the time of mounting ISO images, etc. So it's just, it's meant to be super, super simple and everything integrated. So no like external dependencies that may go wrong, or IP conflicts or service accounts, or you know how integration works or doesn't work. So this is just single binary. It's not even multiple containers. everything's just one single binary for ease. There was a question somewhere in the back, I think. Oh, okay, you withdrew it. Okay. Any other questions? None withdrawn? Okay, cool. So I'm gonna stay here for another 40 minutes. So if you have any questions, just find me somewhere here within 40 minutes or reach out to me in the email at the end. Thank you.